Imagine you're in a system design interview. Your interviewer walks up to the whiteboard and draws 3 boxes: forward proxy, reverse proxy, API gateway. Then they turn around and ask, which one does your system actually need? Most engineers answer immediately, which is exactly the problem. Because this isn't a definitions question, it never was. It's a boundaries question. And here's the thing about getting boundaries wrong. You don't find out in the design phase. You find out when you're scaling. Or worse, when your system starts talking to something you don't control. So before we get into any of this, which one are you actually using right now? And do you actually know why? Oh, let's reduce this to one idea. A proxy is just something that sits in the middle. The only question is, which side is it controlling? A forward proxy controls the client's view of the outside world. A reverse proxy controls how the outside world reaches your servers. An API gateway controls how your services are accessed and governed. 3 different layers: client boundary, edge boundary, service boundary. And this is where things get interesting, because when you introduce one of these, you're not just adding a component. Think of it like a security checkpoint at a building entrance. Everyone who enters goes through that one point. That's powerful. You can check IDs, log visitors, block threats. But that one checkpoint now carries all the responsibility. It slows things down slightly, and if it fails, nobody gets in. That's exactly what a proxy or gateway does in your system. It simplifies the decision of who controls access. One place, done. But it centralizes the risk. So here's the real question. In your system right now, is there a checkpoint doing too many jobs? Auth, rate limiting, logging, transformation, routing, all in one place. That's not a gateway anymore. That's a liability. And the worst part, it won't break on day one. It'll break when you need it most. Now let's zoom in to the client boundary. A forward proxy sits in front of your clients. Every outbound request, HTTP, HTTPS, API calls, flows through it. Think of it like a corporate mailroom. Employees don't send packages directly. Everything goes through one desk. That desk can inspect every package, block certain destinations, log everything that leaves the building. And if that desk shuts down, nothing leaves at all. Technically, the proxy terminates your connection, applies policies, and re-originates the request on your behalf. In HTTPS scenarios, it goes further. It intercepts your encrypted traffic, acting as a trusted man in the middle. Your data is decrypted, inspected, re-encrypted. Inside a corporate network, this is standard practice. Now here's where it gets uncomfortable for SaaS companies. You probably don't run a forward proxy, but your enterprise customers do. Which means right now, your application is running inside someone else's control layer. Domains can be blocked, headers can be stripped or modified, connections can be throttled, requests can be fully inspected. And here's what makes this dangerous. Your backend is healthy, your logs are clean, your monitoring shows green. But the user experience is completely broken. So what do you actually do about this? First, publish your egress domains. Every domain your product calls, APIs, CDNs, auth providers, webhooks. Enterprise customers need this list to whitelist them in their proxy. If you don't publish it, their proxy blocks something and your support team gets the call. Second, respect proxy environment variables. HTTP proxy, HTTPS proxy, no proxy. These are standard. If your SDK or backend agent ignores them, it will silently fail in corporate environments. Third, design for partial connectivity. If one domain is blocked, your entire application shouldn't break. Analytics fails silently. A non-critical API times out without taking down the session. And avoid certificate pinning unless you're prepared to lose enterprise customers. TLS intercepting proxies will break pinned connections every time. Now here's the insight about forward proxies that most engineers miss. A proxy log tells you intent, not outcome. A log entry says a request was made. It doesn't tell you whether the response arrived, whether it was modified, whether something downstream silently failed. So here's the interview question. Your proxy logs show traffic to an unexpected external domain. What do you actually know? And what are you missing? Most engineers answer the first question. Almost none answer the second. So the real question for your system isn't, do we use a forward proxy? It's this. Have we designed our system assuming one already exists in front of our users? Because in enterprise environments, it already does. See, now let's move to the edge boundary. A reverse proxy sits in front of your servers, not your users. Clients think they are talking to your application. They are actually talking to your edge. And that edge decides what reaches your backend. Think of it like the front gate of a secured campus. Every request enters through one controlled checkpoint. That checkpoint can verify identity, inspect requests, and decide where traffic goes next. Technically, this layer does a lot. It terminates TLS connections, so your backend doesn't handle encryption overhead. It routes requests based on host, path, or headers. It load balances traffic across multiple instances, often using strategies like round-robin, least connections, or latency-aware routing. It can cache responses close to users, and it can block malicious traffic before it hits your application. This is where a WAF, a web application firewall, typically operates, inspecting requests for patterns like SQL injection, cross-site scripting, or abnormal traffic behavior, so your origin stays hidden, smaller, and better protected. But here's the trade-off. You've created a single critical control point. And when this layer fails, it fails before your application even runs. Bad timeout settings, random 502 errors, header misconfiguration, broken authentication and sessions, incorrect trusted proxy settings. Your logs show the proxy IP, not the real client. Health check misconfiguration, healthy services get marked as down. And one routing mistake can break every endpoint at once. So here's the deeper question. Are you treating your reverse proxy as infrastructure or as part of your application? Because in reality, it's both. Which means it needs the same discipline: versioned configuration, code reviews, staging validation with real traffic patterns, and separate observability, edge metrics, and application metrics. Because if your edge is unhealthy, your system is already failing. Now, one last thing to think about. A reverse proxy protects your boundary. But once traffic is inside, what enforces trust between your services? Because the edge can stop external threats, but it does nothing for internal ones. So the real question is, where does trust actually begin in your system? Now let's move one layer deeper, because once traffic gets past your edge, most teams try to regain control here. At the service boundary, this is where API gateways live. An API gateway sits in front of your services, not just routing traffic, but enforcing how that traffic is allowed to behave. Authentication, authorization, rate limiting, request validation, sometimes protocol translation. Think of it like a control desk inside your system. Requests don't just pass through, they are evaluated. This gives you something powerful: consistency, centralized policy enforcement. But here's the shift that matters. The moment you introduce an API gateway, you are creating a control point. And control points tend to accumulate responsibility. At first, it's authentication, then rate limiting, then request transformation, then cross-service concerns. Over time, this layer becomes a dependency for every team. That's the trade-off. You gain control and consistency, but you introduce coupling and a potential bottleneck. So here are the questions that matter. If this gateway fails, how much of your system becomes unavailable? Can teams evolve their services without coordinating changes in this layer? And more importantly, what logic are you choosing to centralize here? Because not everything belongs in a gateway. Policy enforcement usually does. Business logic usually does not. When that boundary blurs, this layer stops being an entry point and starts becoming a constraint. So the real decision isn't just, do we need an API gateway? It's this: where should control live in our system, and where should it not? Now here's where most systems start to degrade, not because the components themselves are wrong, but because their responsibilities slowly blur together. A reverse proxy starts handling authentication. An API gateway begins owning routing and orchestration. Security policies get duplicated across layers. And over time, everything becomes the gateway. Think of it like a control room. At first, it just monitors. Then it controls access. Then routing. Then business rules. Until eventually the entire system depends on that one room. Now, a single mistake there doesn't just affect one component. It affects everything. It feels simpler at first. One place to control everything. But that's exactly where the trouble begins. You're no longer defining boundaries, you're collapsing them. This collapse creates three common failure patterns. First, duplicated logic. The same rules enforced in the gateway, and again inside every service. Second, hidden coupling. Services depend on gateway behavior that isn't visible in their own code. Third, brittle cascades. A small change in one layer breaks behavior across the entire system. So here's the fix. Draw clear lines of ownership. Forward proxy, outbound control. Reverse proxy, edge routing and protection. API gateway, policy enforcement. Keep those responsibilities ruthlessly separate. And never assume behavior enforced outside your service will always be there. If you removed one layer today, would your system still behave correctly? That's the real test. Most systems don't fail because they lack components. They fail because their components quietly take on too much over time. So let's cut through the noise. Forget definitions. Focus on decisions. In real systems, you're not choosing tools. You're choosing where control lives. Here's the practical framework. If you need to control outbound traffic, what services can call external APIs, databases, or third-party services? Use a forward proxy. That's your client-side boundary. Think egress filtering, corporate proxy rules, MTLS outbound. If you need to control inbound traffic, TLS termination, rate limiting at the edge, WAF rules, basic routing. Use a reverse proxy. That's your edge. Tools like NGINX, Envoy, Traefik, or cloud load balancers. And if you need to enforce consistent policies across dozens of services, JWTR to OAuth validation, fine-grained authorization, request transformation, circuit breaking, observability headers. Use an API gateway. That's your service boundary, whether it's Kong, Kraken-D, AWS API Gateway, or Istio's gateway. Most teams get this wrong. They let the tool dictate the boundary instead of the problem. So NGINX starts validating JWTs with Lua scripts. The API gateway starts doing complex routing and service discovery. And suddenly your boundaries are gone. Rule of thumb for senior engineers. Every layer should own one clear responsibility. If you can't describe it in one sentence without using and or also, it's already overloaded. And never add a layer you're not willing to operate at 3 a.m. because every additional hop adds latency, another point of failure, and more distributed tracing pain. So stop asking, which tool should we use? Start asking, what exact control do we need? And at which boundary should it live? Answer that honestly, and the right architecture becomes obvious. Let's make this concrete. You're building a CRM SaaS used by large enterprises. Real traffic flow looks like this. User, corporate forward proxy, internet, your reverse proxy, API gateway, services. Two completely different proxies. Two completely different responsibilities. First, the forward proxy, controlled by your customer. It can block domains, rewrite headers, perform TLS interception with Zscaler or Netscope, and throttle requests. So you must design defensively. Never trust client IPs or X-forwarded for. Use JWTs or OAuth tokens for identity. Assume outbound calls to analytics, payments, or third parties can be blocked. Add timeouts, circuit breakers, retries, and fallbacks. Expect TLS interception. Never blindly pin certificates. Validate host names and log when chains look suspicious. Now on your side, the reverse proxy. This is your edge, your first line of defense. Here you should terminate TLS cleanly, enforce rate limiting and basic WAF rules, sanitize all incoming headers, and set trusted X-forwarded data headers only from here. Use Proxy Protocol v2 to pass real client information downstream. Keep it lean, do edge protection and simple routing. Don't push authentication logic or complex business rules into it. The key mindset. Treat the forward proxy as an unpredictable, hostile layer you don't control. Treat your reverse proxy as a clean, disciplined boundary you fully own. One protects you from the outside world. The other protects you from your own complexity. Get both right, and your system becomes resilient in the real world, not just in your architecture diagram. Now let's run the real test. No theory, just brutal honesty. If your API gateway dies tonight, how much of your product goes down with it? If your reverse proxy is misconfigured, what sensitive endpoints suddenly become public? If a customer's forward proxy blocks your payment or analytics call, does the user see a broken feature or just silence? If one internal service gets compromised, how far can the attacker move laterally? Are you still enforcing zero trust inside your own network, or only at the edge? If you deleted your API gateway tomorrow, would your services keep working cleanly, or would they collapse because they secretly depend on it? When your logs look perfect, but customers are screaming, is the failure happening outside your system, in someone else's proxy? And the hardest question, do you actually know where each piece of control lives? Or are you just guessing based on how things behave? Because at real scale, unclear boundaries don't just cause bugs. They turn small failures into total mysteries. At first glance, a forward proxy, reverse proxy, and API gateway can look almost interchangeable. But they are not. They represent three distinct boundaries of control. Client boundary, what your services can reach outbound. Edge boundary, how the outside world reaches you. Service boundary, what policies and contracts apply across your internal services. Most systems don't fail because they picked the wrong tool. They fail because these boundaries were never clearly drawn, or they slowly drifted over time. So here's a quick audit you can run today. Do you know exactly which layer owns authentication, rate limiting, and routing? Can you remove your API gateway tomorrow without breaking half your services? Are you still trusting X forwarded 4 from unverified sources? And most importantly, has the gateway quietly become a God object in your architecture? If you had to explain your current stack in one clear sentence, could you do it? Or would it require a diagram, a wiki page, and 3 meetings? Drop your actual stack in the comments: NGINX plus Kong, Envoy plus Istio, Traefik, Cloudflare plus custom gateway, whatever you're running. I'm genuinely curious how different teams are drawing these lines in production. And if this series made you question even one assumption in your system, then it did exactly what it was meant to do.